Let's give a warm welcome to Mills Davis.
All right. Good. 1, 2. Okay, we're up. Today's one other thing I'm going to just sort of mention will be also there's a little card that talks about it. If you're interested in this whole area of semantic technologies, there are now conferences that deal with it at a research and academic level. But this one, the Semantic Technology Conference in San Jose, coming up in May, is one that's really focused across a spectrum of industry applications, and maybe one that you find interesting. Okay, well, this morning we're going to talk about innovation in the web, and that was kind of the pale title. And I started thinking, well, what would be the take on it? Because the topics are way too big, too comprehensive. And so I thought, well, what happens when the blue ocean meets the semantic wave? Now that, one is about strategy of innovation, and the other is kind of about where is the internet going that's going to condition everything we do. But first of all, here's the brief on me. I have a research consultancy in Washington, D.C. We're very much focused on, next generation internet kinds of things, but it's semantic technology. The second paragraph is sort of talking about some of the communities of practice and some of the industry groups that we're working on that are who are working on different aspects. Semantic interoperability is a federal community of practice that actually works with a bunch of other communities of interest to help them with the evolution of practices, information sharing across various kinds of boundaries, whether those be systems or information silos or organization or jurisdictional and so on, and are looking at ways to policy and structure of data, documents, and work with the semantics and all of those in a form that both people and the computers can work with. A couple other groups, one's the interoperable enterprise content group from the AIM group, and also we're part of the founding of the National Center for Ontology Research, which my quip on that is that my background, by the way, is in philosophy, so it's conceptual synthesis, and so I think of the NCOR as an attempt to build a kind of an underwriter's laboratory for knowledge model kind of thing. So I think of it as philosopher. It's people who brought you the scientific method finally got around to trying to live by it. And so anyway, so that's a little background on me. I guess the starting point I have is first to talk a little bit about innovation, and then talk about the semantic wave, or where the internet is going, and then kind of how these things play off of each other. But the first thought I kind of had was, well, what if everything we know about innovation is wrong? And I'd come across some work by a group out of Chicago called Dublin Research. And we often think that it's about creating the hot new product, but of course that's not necessarily the long-term advantage. It's frequently, it's a short-term gain. The products get copied and so on. It comes from being creative. Well, actually, maybe more often it comes from being able to, a strategy that's executed is better than just having great ideas, and so it comes often more from being disciplined about, making the ideas translate into practice, translate into products, translate into business success. It's expensive. It demands lots of resources. Well, in the current climate, we're now, with globalization, with the internet, with so on, most of the fields that we're involved with, and most of the business and the markets, the pace of competition, the cycle time on products and innovations and so on, are much, much shorter, than they've ever been before. The failure to innovate is what's really going to be costly, and it's more correlated with whether or not we can get the resources applied to it. And yesterday we talked about the tournament kind of notion, create hundreds of ideas. That may be true. It certainly is true for some kinds of innovation. There's no other way to do it. On the other hand, it may be be better about framing the context within which you're trying to innovate. When I talk about the semantic wave, Web 3.0 kind of ideas, it's because some of the kind of innovation that you do over the next 10 years years, isn't arbitrary. It's because the world is changing. It's a hyperstructural reality. It does have direction and shape. Out of all the possible things, some things, you can do other things that in the time isn't right yet, or are just obsoleted by transition. So you need to understand the ecosystem and the trends that are at work in the world that you're working through. And then the final point here is that, well, financial analytics, we go to the venture capitalists and, well, what's the rate of return going to be in year 4? Well, in a lot of things in the current climate, you're better off to just make the prototype, get started, and allow your business model and your innovations success to evolve organically. Okay, so I talked about Blue Ocean. Blue Ocean strategy, I think we've talked about a couple times in the course of the conference already. It was just a good book on innovation strategy, whether it came out in 2004. Here's the main idea. From just focusing in a highly competitive red ocean world to try to innovate in ways that makes competition irrelevant. Get the blue ocean, get the open space. So from the red ocean to the blue ocean, shifting attention from supply and competition and cost to demand. Then the next 2 bullet points kind of just highlight key thoughts of red ocean strategy. We're working to find boundaries of market, competitive things. You were trying to basically, longer, lower, wider, cheaper, faster, better, but trying to basically work within the constraints of a market we think we kind of understand, and we're benchmarking off each other, and so share of market, share of things, these kind of points we're trying to move. Blue Ocean is looking a different way and is basically trying to push the demand creation into an untapped market space. There's some forms and approaches you take to that, but basically what you're trying to do is shift attention to demand, not cost. And you're trying to emphasize new customers or a new definition of market as opposed to doing something better in a kind of a known market, a known competitive space. But here are basically 5 points of comparison. This is basically from the book. The little diamond on the right sort of says, what is it all about? It's, what you're doing in either a red or a blue strategy, you're seeking value innovation. So point number 1 is innovation is about value. Innovation is about change, that has value. Now, what value is, and I mean, it's a measure of the worth, the desirability, positively or negatively. But it's also, it has economic dimensions, has other dimensions. So these are the 2 kind of points. I'm not going to dwell, too much on it. Existing market space versus new, beat the competition, make it irrelevant, exploit the demand, capture a new demand, make a value-cost trade-off versus break that and change the rules of the game. In the coming internet era, there's a lot of drivers for and shaping of the competitive space, and there's a lot of blue ocean possibilities, which is kind of why I'm stressing this side of the argument today. When you think about concepts in innovation strategy, particularly come out of the blue ocean kind of analysis, these 4 thoughts. One is the notion of a strategy canvas. Across from this is upper left hand. Across the bottom of that, it's dimensions of a market, that are, and the valuing of oneself versus others, and then the point being that what you're factoring are things that are the existing market space, kind of to the left-hand side of that, and new factors where you're basically breaking the rules. The second thing, going back to, is innovation about just making a hot new product. Well, on the top right, so from Dublin research, there's basically the comment on 10 types of innovation. They're all aspects of the business concept that you can exploit in innovation, and all of these are functions of design, of planning, of engineering, of thinking things through. Finance, process, the offering, the delivery, the business model, the networking, how one pulls together the value chain, the enabling process, the core process, the product performance, the system, the service of it, and also the whole delivery side, channeling, branding, and one that I think is very important, particularly in well, consumer and enterprise markets, is the customer experience. Then, as you're engineering these changes, then you're trying to figure out what to reduce, what to eliminate, what to create, what to increase, and those are those 4 actions framework. And then the 6 paths, the blue ocean, basically looks at it from the standpoint of the industry or the group, the buyer group, product, service, and what the differences is between head-to-head competition and blue ocean creation. I'm not going to read through all of this. Also, these slides will be in the the super secret website, so you'll be able to download as a PDF and enjoy it. But on the 10 types of innovation, here's a kind of chart that sort of just identifies some companies that have been, singular or noteworthy in how they've innovated in different aspects. The business model is, how the enterprise is making its money, et cetera, and examples of Dell and Walmart and different companies that have excelled in one particular dimension. But the point of the blue ocean idea is not that you just do one thing well. It's also that you do value is a molecule. In other words, you're looking for concatenations or configurations of value. So here's a couple some examples. Again, I'm not going to talk in depth in them today, but it's just trying to stimulate your thinking that here were plays that were made in markets that not only were about product innovation, but in fact covered multiple dimensions. So there are changes in business model, changes in delivery, changes in process, and so on. So looking at what Apple did with music offering and the primary and secondary and tertiary plays that can be made off of it, what Google has done, but it also applies in major product categories. And here's a kind of an overview of Boeing's in the 787. And that, again, the different aspects of thinking of the product, in this case, as platform, as a framework within which a number of entities can grow value, looking at different things from multiple perspectives across, the dimensions in which is valuable. Now, the competitive rub in all of this is, of course, people that are good at this and going through these processes, are significantly better at it than the norm. So there's 6, 9, whatever sigma we want to put on it. But the point being is that the world's best are at least 6 times more successful at getting better products to market faster, and that's what you're basically up against. Now, what it reminds me of in this is that I remember having a conversation at Hewlett-Packard. Gosh, this was like, around the end of the 80s, and we were talking about printers, and they used to be a hardware company, and then they were finding that, more than like half of the resource in development was going into software of various kinds and how to fit it into different contexts in the office and home and so on. And basically they sat down and they said, well, look, here are the 17 or so factors or dimensions on which we can innovate. They said, now we can afford to do 6 of these. The industry, however, is moving on all 17, and so what we have to do is place our bets as to where we're going to be able to establish a proposition that has differentiation from them. And in many respects, across all industries now, with globalization and so on, what we're in is something where the aggregate of all of the players in the ecosystem, the competitive, is able to, in aggregate, we move on a lot more vectors and further. And so what we have to do in terms of our own innovation is be selective and place our bets as to, what kinds of and where, and develop the processes that enable us to cycle through that in a way that allows us to hit the markets, stay in the game, and continue to move. Okay, well, so let's wrap it up. IBM did a study in 2006, which I thought concluded some kind of interesting things. One of which was that 2/3 of the CEOs that they were talking with in this study were making a priority to drive innovation. Not that they didn't have problems doing that, but by God, they're doing it. But the 3 key kind of thoughts is, 1, the business model innovation matters. That's sort of like take the whole concept of the business. So change how you add value. That's the name of the game. But make the business model deeply different. Now, what do you do with R&D people who are geeked out and so on? I remember talking to John Seely Brown at Xerox PARC, and he said we had this problem. We were doing this really terrific innovation, but couldn't get it to market. And he said, and then one day, it dawned on me, that engineers like to deal with architectures. And he said, so why don't we, so I started talking to them about architectures of value. And I made that a requirement, is that not only was the innovation they were working on something, that technically or whatever reason, the paper they were going to publish, but that they think through the issue of the value and how that, where was that going to make value, where was it different, where was it better. And he said they began to respond to that immediately because it was just another design problem. They just hadn't thought on that context before. So make the business model deeply different. External collaboration matters. This is another thing, this is a corollary of our networked way of life. I mean, I find in the semantic technology space, when I put out our study and put out the free summary and so on, the first 3,500 downloads, they're from all over the world. I mean, I may be, in the United States, but people are focusing on these issues now already, always, from all around the world. In aggregate, semantic technology is a smaller percent of the total IT scene, but it's still nonetheless a global niche. Here's the importance of being able to link to your customers, suppliers, that become sources of strong ideas. The challenge is to defy collaborations, collaborate massively, systematically across the organization, geographic boundaries, force the outside look. Not that this is necessarily easy if you haven't been doing it, but in fact this is actually what's going on in the world now. People are already starting to link up, and it isn't like people are giving it away. It's that there's more intelligence outside of your organization by definition than there is in, if you can figure out some ways to get together and make it work for you. And the internet makes this almost an imperative now. Innovation requires orchestration from the top. It don't just happen. The challenge here is to use business and technology and how you integrate the technology and the business processes to ignite the innovation. And I'll be sort of hitting on this theme when I start talking more about semantic technologies. But it also means some orchestration that allows you to structure the organization. Team, also incent, reward the individual innovators, and this can be both within and across your partners or your collaborators. Okay, well, this is where we're going next. So that's kind of the story on innovation and sets the stage. Now, the second point, is kind of important, is that innovation, doesn't take place in a vacuum. It takes place in a context. And the internet is one of the large shaping forces in our world. And where is the internet going? I would say it's going toward what I'll call Web 3.0, which is our next generation, next stage of internet evolution, whatever term you prefer. But what's that? Well, it's what happens when you have lots of web, it's everywhere, lots of semantics, which is, what are semantics, we'll get to in a minute, and lots of social interaction with all of this, both in disciplined ways and pell-mell, and kids with, phones and everything. So the triptych here was kind of, what would happen if Roy Lichtenstein, met the semantic web. And the first one was a girl is like pining away trying to figure out how to stay ahead and what to choose. And then you start getting into using these models independently and so on. And so, why can't we link these things together? That's kind of what the problem the BIM people are having now. But at the end of the day, people are going to be really pissed off if, the computer doesn't understand what we want. That's the point about, why doesn't this phone know that I dump Brad? So anyway, but what's the context in which I'm talking about the evolution of the internet? Well, evolution of the internet to 2020, we're looking at here as kind of 4 stages of internet evolution. First generation web was about connecting information, getting online, basically creating points that we could point to and click. The second kind of push we've been going through is more about can you hear me okay? Is this mic going down? Okay, great. The second stage of the internet is the social web. It's about connecting people. We put the I in, user interface, put the we in the web, Times person of the year is you. In the third stage, and the 2 dimensions here, by the way, is kind of left to right, is increasing social connectivity. And social connectivity in this sense means people and things. And then the vertical axis is increasing knowledge, knowledge connectivity, connectivity and reasoning power, and I'm going to talk a little bit more about what that means. But stage 3, semantic web, connecting the knowledge. There's basically a shift here, and then as you start to look at it as what stage 4 is, well, by 2017, for example, the mobility crowd sort of says to us there'll be 5 billion telephone, devices with mobile devices with IP connectivity. Excuse me, there'll be 5 billion people with that and 7 billion devices. In such a world, you're going to have fundamentally some different rules. Its context is going to be king, being able to shift and orchestrate services. This stuff is, isn't going to be done with, central planning. It's going to be something that's going to be the intelligence for that must be highly distributed. And local devices must be able to sort out what it is you just happen to walk into, that point or that sign that's trying to communicate to you, or what that building is that you're pointing your camera at, and so on. And these things are not, predefined before you went there. It's all going to be happening on the fly. And it will be a ubiquitous web that connects intelligence, that people and things will be participating in the same social dialogue. So that's our kind of context. Not that these are fixed stages and so on, but because innovation's working on all of those, but just that also that there's this kind of a certain order where these will be kind of predominant. My argument, though, to you today is that the semantic web stage, or the Web 3 kind of stage, has already started, and there's a fairly significant amount of effort, and that's what our research is basically build up a case. We're tracking at least 300 companies, reported out at least 150 case studies of interest, and so on. Okay, but what's so different about Web 3.0 is a fundamental shift, and the paradigm shift is between information-centric to knowledge-centric patterns of computing. The corollary for this, and I'll just toss this out today for fun, is that I think things like stack architectures, object orientation and stuff are going to turn out to be training wheels for something that's a little deeper and richer. And when we talk about infrastructure issues a little later on in the talk, I'll give you some examples of why I say that. But the semantic technologies are basically digital tools that represent meanings, associations, theories, know-how about stuff, separately from artifacts like documents, data, and program code. So it's the world of smart data that's interpretable both by people and by machines. And then where is this semantic technology kind of being worked on in R&D context? This diagram basically kind of gives you some areas, and all of those areas have significant, actually public sector and private sector funding going on, not only here, but in Europe and in Asia. Now, how do semantic technologies add value? Remember, it's all about value because we're innovators here. And, we may just have simians with attitudes, or that, shocked and amazed woman there. We may have, Charlie Brown, trying to get semantic with his, syntax and lexical and ontological theory. We may have machine learning. But basically, it's a combination of, the pattern reasoning, the deep linguistics, symbolic reasoning kind of capabilities. But what we're doing is essentially we're representing the knowledge. We're pulling the knowledge out of things like algorithms and objects and so on, and making it a form we can access them not only within the program but by other devices. And this has some rather good ramifications for us. We're adding intelligence, which is knowledge about stuff, and we're enabling architectures that learn. In other words, systems that can get better with scale, with use, systems that can sort some things out, systems that, in collaboration with their users, can learn new tricks. And this has some pretty important ramifications in terms of, how do you keep environments fresh. Just as a thought here, you have to also remember that, we've been doing semantics, since we were, born. If we didn't, we'd be food. But how humans encode ideas. We all have a lot of experience coding and ideas. We do it in different ways, but it's about patterns and it's about language. And so on the left, we're sort of talking about, natural language, visual language, formal, behavioral, and so on. And different people use different types of language, better or worse. And on the right, I just put some diagrams about visual language, which I think is really important, and it's a well-developed area in CAD. But what I would argue for you is actually what the internet has brought us is a stage where we've gone from kind of passive visual understanding to a set of active visual vocal cords on a global scale. We may be at the grunt stage of this, but we're moving there, and that actually visual language is becoming the adjunct language, and in the same way that Latin was, you know, in the ancient times, or French might have been for diplomacy in the 1800s. PowerPoint culture, but also many other kinds. You know, a student today would be expected to know how to make a video, would be expected to know how to, you know, to put a presentation together. I mean, it's just, well, duh. When I grew up, you know, drawing was for little kids or for artists, so strange people, or somebody did something weird, and other people learned how to write and do Palmer method or something. And the answer is really one of the corollaries of the semantic wave is the expansion and evolution of language, and language in a sort of the transsemantic sense of different forms of representation that we can work with comfortably, but also our computers can, you know, can synthesize and help us correlate. So we're looking for some advantages from that. And by representing knowledge separately from the artifacts, of course, we get to exploit the, you know, different kinds of capabilities. And so I want to kind of go on to that. We hear a lot of talk about search. Of course, in knowledge, there isn't any search. You either know it or you don't know it. Just keep that one in mind. Also, the economics of knowledge are quite different than the economics of information. Knowledge is something you put a lot of effort into, like once, to learn, and you get to use it for a while. Information is the changing face of reality that it's like the newspaper, you have to buy it every day because something's different. In decisioning, probably 80% is the knowledge side, or what we our theories about reality that we somehow learn and can continue to apply, and the smaller portion of it is the information. We often talk about being inundated by information, but all reality has been inundated. We're all, you know, computing this. But there's no reasoning without representation. So this chart, looking in the vertical axis, is kind of showing you different types of knowledge representation, and then kind of to the right of that, giving you example of the kind of structures or standard formalisms and so on, with a kind of an IT kind of thing on the right-hand side that sort of kind of tells you what kind of, you know, interoperability we can pull off if we do that. And if you look along the bottom, it sort of says what kind of reasoning power capability do we have as we kind of deal with more encompassing and more powerful forms of representation, and we move from recovery to discovery to intelligence to question answering to smart behaviors. Now, this slide, I could talk for a while on, but I just kind of want to give you a notion that, you know, we've already been using, you know, we talk about folksonomies. You know, if you want to know the future of folksonomies, look at what a dictionary is. But, you know, we start with tags and words that matter, and then we build, you know, relationships between them. Some of those relationships are, you know, hierarchies and sets. Some of those things are equivalences or associations. We move on to conceptual models. More powerful things, when we want to build a bridge that doesn't fall down, we need some logical theories, you know, first-order logic and whatnot. When we begin to start deal with real serious stuff, we begin to realize that serious human reasoning involves, you know, conflicts, uncertainties, values. Questions of guilt and innocence involve more judgments than whether it's logically true or false. And so that moves us into, you know, other forms and modes of logic. And ultimately, it's about values. Again, innovation, value, axiology. So what does that mean? Well, that, you know, for example, in the case of search, you know, it moves us in different directions of things that we can do and link across and work at things at a conceptual level, actually answer questions as opposed to just returning lists of documents. Over on the right-hand side, we're doing discovery, and above that, we're mashing together different kinds of information because the knowledge about that, you know, we want to link things together. First you integrate the knowledge about it, you know, then you do it. But what's happening in this information to knowledge transition is basically can be thought of too in terms of, you know, the dimensions or perspectives on the technology we're doing. And I would argue that anything we look to innovate in terms of product and so on really has these kind of dimensions to it. And the way you kind of read the quadrants is that, you know, you have on the top you have individual, the bottom you have collective or plural, and you have interior, i.e. how I see it, my experience, how we, you know, think about it, communicate it, the shared values kind of side. You know, what we're talking about as an object viewed objectively, its structures, its properties, technologies and what we do when we think systemically, or whether it be social or so on. So these kind of perspectives, semantic technologies, one, embrace; two, allow you to synthesize; and three, become the basis for some very interesting innovations that should be considered. So when we think about user experience, again, in the handout that's on the that's in the what it was on the little gigabyte stick. You have some discussion of this, and if you want to go further into the things we've done, our report, of course, goes into this at some length. But basically, one key area. One thing we learned from Web 2.0 is that the user experience, user interface, is an important thing to attend to. What we're going to get with the knowledge thing is that we can then tie and link things together. We can have interfaces that actually know something about the user and the tasks they're doing, the personas they're experiencing. We're going to have intelligence about all of those kind of yellow things on the top, or all the places where displays might occur in the environment. We have, reality browsing that is able to integrate the cyber and, the experience in the world and be able to make sense and interpret that. We're going to have whole new categories of devices. And, of course, for fun, I thought I'd kind of do a little flashback. On the left, from the RAND Corporation, circa 1965, is a picture of what a home computer might be like in 2004. On the right are some examples of personal devices, et cetera, and touchscreen display and so on, that circa 2008. So again, be careful what we ask for. Now, one of the things, as we sort of move from the there's the realm of the user experience is kind of the me. What's in it, how does it work for me, and so on. The social side of that, or the cultural side of that, has become very important with the idea of technologies of cooperation. This chart came from a study by the Institute for the Future and the Cooperative Commons, and basically the premise is, any time in human history when we had a fundamental innovation in communications, that in turn leads to changes in societal practice, culture, and so on, that are in the direction of being able to collaborate and collectively work at larger and more complex scales. So in this thing, it's a story of the coevolution of tools and social practice to support ever more complex form of cooperative society. It happened with the printing press. We ended up with clocks and everybody, having to learn to read, but not because illiterate people were bad. It was that it was so much more advantageous to be literate. And we're now in an internet era where this whole notion of collaboration, of being able to work across groups, is not that by being your own little corporation, doing your own little thing is bad. It's just going to be a lot more advantageous to be able to work in this space, QED. Now, in social computing, lots of stuff could be done, could be talked about here. I love the nun sitting on the chair there with the little legs. But anyway, the point about social computing is that the killer app that's coming our way is going to be what I would call collective knowledge systems. And this is things that combine, the ability to extract and represent the knowledge, and the ability of people to interact with that and manage it and involve it. And this will be very important again, if you think about the collaborative context within which CAD, engineering, design build processes, the entire communities and ecosystems which these take place. These are these are techno-social, economic, collaborative contexts, and social computing is absolutely an essential dimension. When we start to think about this, particularly from an enterprise point of view, and we sort of say, well, where would we see semantic technologies being employed? You can read this diagram at your leisure, but the basic idea is, if we were looking at the axis of decisions in operation, we're looking at customer to supplier, we're looking at, from idea to its manifestation in product or service, the development chain. The point is, about everywhere, there are examples of this, and, in our study we documented these all over. And these are, so it's, a lot of different opportunity. So we have new capabilities that are, related, the most powerful ideas, of course, are always related to new concepts of operation too, and extremely improved life cycle economics. I mean, we're talking, the 10x idea. I can give you, plenty of examples of stuff that's, 10 to 100 even. So these will come about. Also, what we're seeing is now we look at what's happening at SAS, SAP, Oracle, Microsoft, is that the major IT companies are starting to see, there's going to be some significant advantage to us if we can start to embrace these technologies. Maybe not the most sophisticated thing right up front, but probably the starting place is going to be in the middleware, right? Because it has the least impact on the customer, but allows us to refactor our own processes. But here, it shows on the left, in addition to the robot, solving the Rubik's Cube problem, you have things that are from the from the commercial off-the-shelf software area, applications. All of these are candidates. Anytime you have of applications that deal with graph representation of information. Sound familiar? These become also candidates for semantic applications that allow you not only to have what that represents, but be able to connect it and match it up with other kinds of information in order to do simulation and so on. And anytime you put theory into the computer, it cries out for for testing, for validation, and so on. So one of the key areas that semantic technology is going to impact significantly would be what I would call virtual manufacturing or knowledge-centric engineering. When we move from document-centric practices to knowledge-centric practices, i.e. we don't just use the computer as electronic pencil, but we then allow ourselves to move in very interesting directions. Strong economic reasons to go that way, strong cultural issues to overcome, but I think it's inevitable and inexorable. An example in the life sciences area, this one, BioCAD, was one that basically was kind of interesting because what they did is in the middle it's all semantic models, actually semantic agents, in the Marvin Minsky Society of Mind kind of way. And they had simulation and tests, they had pathway modeling. The people that are working in cell pathway modeling are folks that have a graphic discipline for how they model. And what's happening is as they drag and drop and do their symbols and their pathways, which are really cascades of signal pathways, etc. They're becoming, they're hitting the database, hitting the semantic. They're being played out against public databases. Public databases in this case are also ontologies, and also genomic, proteomic, experimental databases, and so on. And they're doing like declarative simulations. These are kind of graph represented kind of simulations. This is similar to things that go on in CAD, but not as probably as widely as it's going to be. But certainly we tend to think these as often as point applications. But this is an entirely integrated world that also provided private research, lab book kind of service, as well as publication service. The point is that when you think about something like in silico science, it's the process of being able to put the knowledge to work. Like most of the time when people talk about knowledge management, they're basically thinking bibliographically, and well, how could I find something in a document? What about if you represent the knowledge that's in a document, the way you can actually work with it? A computer takes things on. The diagram on the lower right kind of just illustrates a threat neutralization scenario in the government, which brought together all of those hexagons are all different knowledge bases that were over a several-year period integrated together, and basically the steps down the right-hand side across the bottom are kind of the rational thread. There's the notion that when you're reasoning in a declarative world, that if you reason one direction you get how, and you reason the other direction you get why, and you take a bundle of these things you get the what ifs. A lot of issues in decision support are not about a right and a wrong answer. You have a PhD down the hall that can do that, but are when you need to get these trade-offs exposed such that people can actually take decisions. Talking about semantic infrastructure, there's some problems, there's some fundamental shifts that are going to be taking place, but by going to this idea of a knowledge space, you basically have the wherewithal to start really digging into some problems, and problems with scale, complexity, security, autonomics. There are a couple other ways I could look at it, but that in our current philosophy of doing layered architectures or segmenting things from one another, we're finding we're reaching kind of the limits of what we can do, and what's happening now. 5 minutes? Great. I'm going to make it. But if we think about mobility, again, what we're trying to look ahead towards and sort of see if our innovation strategies are in line with is we're going to have a world that's got increasingly some intelligence built into lots of different stuff communicating with us. And so the corollary of that is we need things that are easy to create by end users, do-it-yourselfers, self-describing, context-aware, context-adjusting, and so on. These particular diagrams on this chart, with the exception of the joke about what's the wrong way to tell somebody about implanting an RFID chip in your brain, the others are basically from, well, you have to put a little something in for relief. But these are basically diagrams from different research communities in mobility in the United States, in Europe, the World Mobile Federation guys, the Koreans, and basically letting you know that they're all over this concept of semantic approaches in order to get to mobile computing and then ubiquitous web computing. Here's a kind of a variation on this as well. What's a service-oriented knowledge utility? Basically, grid services and context. What's happening is we're adding semantic descriptions to everything, such that we can automate dynamic composition, reasoning over these things, accounting, other kinds of administrative kind of functions. And what they're finding as they go down the path of grid was that the original assumptions were we could do this with stack architectures and so on, and now they're finding out what I really need is a knowledge plane that's kind of orthogonal to all this stuff that because I need to be able to interrelate policies to different levels of the stack and so on, and so we're finding that for all of these kind of categories of web and web services and so on, that actually there's a shift of architecture. The internet isn't mobile friendly as we thought. It was an internet, but it sort of kind of had fixed interfaces, and so now we're talking about next generation web, and next generation is going to have semantics at the core. Okay, with only a few scant seconds left, the summary is for today, the takeaway is, okay, innovation. Fundamentally, innovation is about value. Now, value, as we said, is measure what's desirable, what is wanted. But innovation is basically about the design, engineering, delivering of a new configuration of value, and that value is itself contextual. It's multidimensional. It's not just one thing, and it also co-evolves in a context and has this it's a survival system. There's an ecosystem going. And the architecture of value, I think, ultimately is a key discipline for the CAD community, to embrace in order to, work in its own context with, to achieve successful innovation. On the web side of it, we're seeing the web has emerged as this force that both drives innovation and shapes or constrains, the forms it can take. We have a global communication information sharing, which is now key, to an evolving, I'll use the phrase, techno-social economic ecosystem, and which both affords and constrains innovation opportunities. The next stage of internet evolution, which we've been discussing, has already started and represents a long wave of investment. There are fundamental shifts in paradigm in technology and economics. But what I would ask you to remember, as those of you who talked about the singularity yesterday, is that nature loves to double down when a bet seems to be working. And by the way, the internet is a bet that seems to be working. So the key to this next stage of the internet evolution is the transition from information-centric to knowledge-centric patterns of computing. And on that, I thank you very much.